Welcome to this S2 video on the normal distribution. Today we're going to be looking at finding Z values from probabilities. That's going to be using the standard normal distribution cumulative tables, but also the percentage points tables. To do this, we're going to just look at a couple of examples to explore all the eventualities that we could encounter. So in example 1, we're asked to find the value of the constant A such that we have these 4 different scenarios which will allow us to explore 4 different ways that we have to use the tables. So let's start with part A. Find a probability that Z is less than A such that it's equal to 0.7963. Now sketches are really useful for this. So whenever I'm doing less than A, I'm looking at this left hand tile. Since it's 0.79673, what I know is it's going to be past this 0.5 point, and so I'm looking at a probability that represents this part of my distribution. Now what that means is, if it's in the positive part and it's less than, I can read directly from the tables. So I'm literally looking into the tables and I'm looking to find a value of 0.7963. Notice it goes from 0.5 to nearly 1 in increasing from left to right, top to bottom. So all I have to do is find the 7s. There's a 7 9s, there's 7 8s. So if I come along, there's 7963. So just highlighting across, I can see that's 0.8. and it's going to be 0.83. So what I know is probability Z less than 0.83 is equal to 0.79673. Therefore, A is equal to 0.83. And that's all there is to it on this example. Okay, so let's move on and have a look at another example. So here we have probability of Z greater than A is equal to 0.2169. Now what I know is when I'm doing greater than A, I'm looking at this right hand tail. Since it's less than a half, so it's going to be on the right hand side of this point up here. So I'm looking at this upper tail here. Now what that tells me is the probability that Z is greater than A, that's going to be equal to 1 minus the probability Z is less than A. So if I set that up as an equation, 1 minus probability Z less than A equals 0.2169. What I'm going to need to do is rearrange this equation, so I'm going to add probability Z is less than A to both sides, so it's positive, and I am going to subtract 1 from both sides to collect all the constants on the other side, so I get that probability Z is less than A is equal to, and when I work that out, I get 0.97381. So again, I'm just looking in the table to find 0.97381. So coming down, I'm in the 9 9s, here's 9 7s. So coming across a little bit higher, here we go, and there's my 0.97381. So I know it's going to be 1.9, and the tail of my answer is 0.94. So at this stage, we know probability Z less than 1.94 is equal to 0.97381, and so A is equal to 1.94. Okay, let's have a look at our third example. Third example says find a probability that Z greater than A is greater than 0.93189. So again, we're looking in this right hand tail because I'm going greater than, but this time because this probability is greater than 0.5, what I know that I'm looking for is a probability down here, which is going to be negative. Now, we know to find negative probabilities, we can use the symmetry of the graph. So instead of it being probability z greater than a, what I'm actually going to say is probability z less than minus a is equal to 0.93189. At this point, I've got probability z less than a. Remember what we're talking about here now is a probability like this. So I can read this straight from the table. So I'm looking for the probability, 0.93189. So have a look and look at here's the 0.93s, 93, there you go, there's 0.93189. Reading straight across, you have 1.4, it's in the final column, so it's 1.49. So probability of z less than 1.49 equals 0.93189. Now what you have to remember at this stage is that 1.49 is negative a, so a must be minus 1.49. And that's how we start to deal with negative values. Again, the sketches are key here just to help you, remind you where all these values are coming from and how we're using our tables. Okay then. Final one using the standard normal tables then. We've explored 3 of the 4 possibilities. Here's our fourth and final possibility. This time we're going to do the probability z less than a is equal to 0.01876. Now if it's less than a, well, I know what I'm going to be using. I'm going to be using the left-hand side of my distribution. Because this probability is less than 0.5, I know that I'm going to be to the left of the midpoint. So I'm going to be looking at a tail like this. So that again is going to be in our negative range. So what that tells me straight away is, in fact, what I'm looking for is z greater than minus a equal to 0.01876. And again, we're using the symmetry of the graph. So in fact, what I'm looking for, if I had this graph, is I'm looking to read the tables to find a probability like that. Now, in order to find probability greater than, I know that I'm going to have to use total probability. So I'm actually going to be finding 1 minus the probability of z less than minus a equal to 0.01876. Going to have to solve this equation like I did a moment ago, so I'm going to add 1 to both sides. So not add 1 to both sides, I'm going to add the probability z less than minus a to both sides, and I'm going to subtract 1 from both sides. Okay, so what this gives me then is probability z less than minus a is going to be equal to, and on the right hand side what we get is 0.98124. So now I could just read this from the table, probability z less than, so let's find this value. I'm looking for 0.98124, so the 9 eighths, here's my 9 eighths, and I'm looking for 124, so here we go, here's my 124. So coming across, I get 2.0, coming up, I get 2.08. So probability z is less than 0.2.08 is 0.98124. And so a, remember to take the negative value, a is minus 2.08. Okay then. So now let's move on and have a look at using the percentage points table. Percentage point tables allows us to read any percentage, the probability for any percentage. So let's have a look at these examples. Here we have find the probability of the constant a such that probability z less than a. You can see here I've got 87%, 24%, 97.5%, and 8%. Now the way we read these tables is very similar. So let's have a look at these 4 examples. So first of all, probability Z less than A equals 0.87. So what I know is if my percentage is greater than 50%, less than, I'm reading the left-hand tail, so what I'm going to be looking at, greater than 50% is going to come up here, and because it's less than it, we're looking at the lower tail, so I'm looking at this. And that means I can read directly from the table. So all I'm looking to do here is read it a little bit more like the traditional tables like binomial, etc. I'm literally going to find 0.80, there's 0.80, and I come across until I get 0.87, so the answer is 1.126. So probability Z less than 1.126. And what these tables do is allow you to find specific percentages as opposed to specific Z values. And so A in this case is 1.126. Okay, let's have a look at B. B wants me to find probability Z greater than A is equal to 0.24. So I'm using the right-hand tail. If I'm using the right-hand tail, I want a probability less than 0.5 here. So it means it's just going to be finding a little tail up here. So I know what I'm actually finding is 1 minus probability of Z less than A equal to 0.24. Okay, so now what I need to do is I'm going to add probability of Z less than A to both sides. And I'm going to subtract 1 from both sides. So that I get probability Z less than A is equal to 0.76. And let's not subtract 1 from both sides. Sorry, I don't know why I'm subtracting 1 from both sides there. I should be, in fact, subtracting 0.24 from both sides. And that would be the same on our previous ones. So, finding 0.76, come along, 0.7, reading all the way across to 7.76, and so we're going to get that probability Z less than 0.706 equals 0.76. And so A equals 0.706. Okay, let's look at part C. Part C says find the probability that Z is greater than A is 0.975. So again, we're looking at this right-hand upper table. I want it to be a big value greater than 0.5, so it's going to be to the left-hand side of that 0.5 marker, and I'm looking to find this probability here. That means I'm going to use the symmetry of the graph, and what I'm in fact going to do is I'm going to find this probability here. So I'm going to actually find probability Z less than minus A equal to 0.975. Now what you'll notice for the percentage points tables is you can find all the percentages from 50% up to 95% in one table, and then from 95% to 100% in a separate special table. So here I'm looking for 0.97. I'm going to read across from 0.97 until I get to 0.975. There's 0.975, and so I get the fact that we have probability Z less than 1.96 is equal to 0.975. And so when I identify A, I just need to remember this 1.96 in fact represents minus A, so A equals minus 1.96. 6. And reading this special table for the one for 95% or more is exactly the same as reading the other percentage points table. Okay. Final example now. Find the probability z less than a is equal to 0.08. So what I'm looking at is a left-hand tail, but it's less than 50%, so I'm looking at this small tail here. Now what I'm going to do is, because I'm in the negative zone, I'm going to use the symmetry of the graph. And I'm in fact going to find the probability of this tail up here. So I'm going to say probability z greater than minus a equals 0.08. This means I'm going to have to use total probability and do 1 minus the probability of z less than minus a equal to 0.08, which means subtracting the 0.08 from both sides, not 1, and adding the probability of z less than a, that's less than minus a, should I say, to both sides. So that I get probability z less than minus a equals 0.92. So we're going to go along, we're going to find 0.9, here's 0.9, I'm going to read across to 0.92, that's as far as I go, so I get 1.405. So we know probability z less than 1.405 equals 0.92. And the last little bit is just to remember that this value here, 1.405, represents minus a, so a would be the reverse and a would be minus 1.405. Okay, with these minor exceptions of adding and subtracting ones, I hope that this video has made sense and explained the notes fully for you.